Hello, in this episode we are going to talk about PID controllers. If you remember the continuous systems, I said that there are two ways that you can find PID controllers in the continuous library. Also in discrete systems we had the PID controller. Here I want to show you a system and set a PID controller in it and see the system response. The system which I want to simulate is an applicative and physical system in the real world. So I use the transfer function, step, scope, I implement the transfer function, and then I go to designing the controller. Okay, this is the transfer function. I don't change the step function. This is the output. Let's set a PID controller in the system. But first, we should set a feedback for the system. Because the feedback should be entered by minus mark, we should add a sum block to our model. Okay, this is the feedback. And this is the output of the model after we set the feedback. Now I want to set PID controller in the system. The amounts of the PID controller are predefined. PID controller stands for proportional, integral, and derivative. It is very applicative in engineering and industry. Proportional gain amount is 1.89. The integral gain is set 1.89 divided by 1.23. Derivative gain is 0.2. Okay, simulate the system now. You can see the output with controller that reduce the error in the system. Okay, thank you. Thanks for being with us. We hope to have you next episode too. Bye bye.